Welcome back. This is the third video for section 5.5. Um, so now we are going to look at how to do this u substitution in the definite integrals. There are two methods. You can use any, whichever you feel comfortable with. Not too big a difference, but the main thing is in method one, we don't change the bounds in the we don't change the bounds. But you have to be careful because what is going to happen here, we are going to use a u substitution and we are going to get rid of the current or the present initial variable in the integral. So if it was x, so we have to get rid of x and everything should be in terms of u. And if it was t, again, we have to get rid of t and get everything in terms of u. And then when we do this substitution, you have seen in previous problem, integral becomes much more simple. And then we take the integral, so antiderivative, find the antiderivative, and then this is an important step. You have to put it back in x form, so, and then plug in limits. If you forget this step, this one, very important, okay, and then plug the limits. This is where students can make a mistake, and so that because the limits initially were for x. I like the second method better because then you don't have to worry about plugging back. So in this case we do find the bounds on u, so and then make a substitution. Of course, then we have to change the limits or the bounds as well. And then we just solve the definite integral. So I'll show you both ways, not every problem both ways, but like this I will do first by the first method, then the next one I will do with the second method. Okay, so here we are, first integral 0 to pi over 8, and inside here I have sine to the 5 2x cosine 2x dx. So as I think someone earlier mentioned one, that we can, if we write it like sine of 2x whole thing to the fifth and cosine of 2x dx. So then we can see that this function is inside, so we can pick that as our u. But you might say, but this one is also inside. So yeah, you can try, picking that as u first. So when you do that, you will not get much simplification, except for here you will have just one. For example, you will have just theta or u, and u here. That's all it will do. So let's not take that as u, but the sine of 2x as u. So I say let u equals sine of 2x. So if you recall the chain rule, so you get du equals cosine of 2x into 2 du dx. So dx will be equal to du divided by 2 cosine of 2x. Now we come here. So I'm just going to ignore the limits for now. So I'm going to just change this function to u to the fifth cosine of 2x times du divided by 2 cosine of 2x. So remember, as we desired, the cosine 2x cancels out. We are left with 1 over 2. Oh, by the way, will this 2 cancel this 2? No, that will be wrong. Okay, be careful about these steps. Okay, so we have inside u to the 5 du. So integrate, 1/2 stays there, u to the 6th over 6. Now we will not do this 2 plus c, but now I can simplify and plug in the u back to x. So 1 over 12 sine of 2x raised to the power 12. So raised to the power 6. Or in other words, 1 over 12 sine raised to 6 of 2x. And the limits are from 0 to 5 over 8. So now plug in the limits. I have 1 over 12, I can keep it outside, and I get sine 6 power 2 times pi over 8. Minus 112 is outside, so sine the 6 of 0. Sine of 0 is 0, so this quantity goes to 0, and we are left with 1 over 12 sine the 6 power of pi over 4. What is sine of pi over 4? That is square root 2 over 2, and we are raising it to 6 power. So what do we get? One over 12 times, so 2 to the 6 is here, let's see. So 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 74. 64. So we have 64 at the bottom, and then square root. When I do square root 6 times, I have square root of 2. I'll write 6 copies of square root of 2. So you see, these two combine and become 2. These two combine become 2, and these two combine and become 2. So 2 into 2 into 2, so 8. And so finally 1 over 96y, because 8 1s are 8, 8 8s are 64, and we are left with 1 over 12 into 64, which is 1 over 96. Okay. Let's look at the next example. Okay. So this is x e to the minus x square, and the limits are from 0 to 1. So we will take the u as, can you guys see it? So this, we know that the integral of e to the x is equal to e to the x. We know that. So here we don't have e to the x, but e to the some function. So what we want is this some function to become single variable. So if we set u equal to that quantity, then we will get a e to the u here. So du is negative 2x dx. So dx will be equal to du divided by negative 2x. And now we come here. Oh, by the way, so we are changing the limits. So here, when x is 0, from this substitution that I have here, that gives us our, that helps us change the limits. When x is 0, u will be negative of 0, which is 0. I mean, I don't have to write this step, but just to show you. When x is 0, u is 0. When x is 1, u will be negative 1. Now just plug in and change the limits. So this was 0, this is negative 1. So x e to the negative, e to the u du divided by negative 2x. Again, x and x get cancelled. We have negative 1/2, I can bring it outside. Negative 1 over 2, integral from 0 to negative 1 eu du. So I will integrate now, negative 1/2 e to the u. Should I plug in the limits now, or should I transfer this back to x? So remember, we are finding the limits. This is the method 2 I am showing you here. Can you see it? It looks shorter than the other one. I mean, I like this one better, but it's your choice anyhow. Okay, so we have now is equal to negative 1/2 times e to the negative 1 minus e to the 0. E to the minus 1 is 1 over e, and e to the 0 is 1. We get this. Or if you want to do a little bit more algebra, we can take the common denominator and we will distribute this negative sign. First, let's distribute the negative sign. So inside I get 1 minus 1 over e. Now take the common denominator, so 1 over 2 times e minus 1 over e. Or final answer, e minus 1 divided by 2e. I hope everyone got this one. Now what about the next one? So this is saying natural log of t divided by t. Now, it doesn't look complicated. I mean, there is no composition here. So what should we take as u? So we don't have like an inside. So it's we cannot quickly pick u. So we have to think about it. And also remember one other tip for picking a q was that its derivative should be present. So which function's derivative you see? What is the derivative of ln of t? 1 over t. Yes. You see 1 over t here? Remember ln of t over t. You can think of it as ln of t into 1 over t. Or it can also be thought of as 1 over t times ln of t. Both are the same. So thinking in that manner, we see that the derivative is being multiplied here. The derivative of the function ln of t is being multiplied. So let's take ln to be u and see what happens. U equals ln of t. So du will be 1 over t dt and bounds. So dt will be t into du. Bounds. When t is 1, u is, so remember we will plug it in here in the substitution that we made u equal to. So u ln of 1, which is 0. When t is 2, u will be equal to ln of 2. Okay, come here and we try to plug things in. Okay, so what happens equal to integral. So I'm going to not write the limits. No, actually I can write the limits, right? I'm doing it the way I like it. I've changed the limits. So limits will be 0 at the bottom and ln of 2 on the top. Okay. And inside we get, so ln of t is u. So we have u over t times, well, dt was t du. So t du. Now t and t will cancel out and we are left with 0 to ln of 2 u du. So which gives me u square over 2, 0 to ln of 2, which is equal to ln of 2 whole square divided by 2 minus 0 over 2. So it is just ln of 2 whole squared divided by 2. Now, can we bring the 2 out here? Or can we cancel these two 2's? This one and this one. None of that can be done. So this is your answer. Remember, the power will come down if you have something like this, ln of 2 to the third. Then you can write it as 3 ln of 2. But if you have ln of 2 whole square, that is a completely different thing. You cannot actually do anything to it. It will remain as it is. Okay. So next one, we have integral from 1 to 3 cosine of pi over x divided by x square dx. Okay, again, what is u? That u equals pi over x. Now remember, pi is a constant, so you can think of it as pi into 1 over x or pi into x to the negative 1. So du is equal to negative pi x to the negative 2 dx, which can be written as negative pi over x square dx. So dx will be equal to negative x square over 5 du. Bring here, plug in the limits or limits. When x is 1, y is, u is, so u was pi over x, so it will be pi. When x is 3, u is pi over 3. So this becomes limit from pi to pi over 3. Cosine of u over x square multiplied by, what is the dx? This is our dx, times negative x square over 5 times du. We have cosine of u over x square. X square and x square cancel out. Du doesn't go cancel out. X square cancel out. So now I'm going to bring the negative sign and the 5 at the bottom out. So we get negative 1 over 5. Integral from pi to pi over 3 cosine of u du is equal to negative 1 over 5. Now what is the sorry, what is the antiderivative of cosine of u? This sine of u, and the angles are okay. Then negative 1 over 5 I keep this outside, and then sine of u first will be sine of pi over 3 minus sine of pi. Sine of pi over 3. that is square root of 3 over 2. And sine of pi is 0, and we have a negative 1/5 outside that I forgot to write there. Square root of 3 over 2, which gives you the final answer as negative square root of 3 over 10. Okay, last problem here. Sine of cosine x dx. Sine x times, note here, this is not sine x into sine x. This is sine x times sine of cosine x. So again, this second this expression is not a product. This is a composition. The sine of cosine x, not sine into cosine. So you have to be careful about this thing. So what do I take as my u? Well, I see cosine inside something, and then I can see its derivative disregarding the negative sign, which is a constant. So we can take this as u, and this will be because that is the derivative of u, except for the negative sign. So I'll let you try, and then in a couple of minutes I will be doing it for you. This shouldn't be difficult. We start by saying let u equals cosine x. Then du equal to negative sine x into dx. Pounds. Okay, let's do it with the method 1. Sine x dx. So I find dx, which is negative du over sine x. Come here, so it will become integral. I'll keep the sine x here, times sine of u. And in place of du I have dx, I have negative du over sine x. So can I multiply them? No, but I see that this cancels out with that. We get integral, negative outside, sine of u du. Now you should be able to integrate this. So negative of what? The antiderivative of sine is? Well, derivative of sine is cosine, antiderivative will be negative cosine. Which is equal to, note here we don't put the plus c. We know that it's a definite integral. Now we'll put limits. It will be, but cosine of u, which is equal to cosine of cosine x. So I have to bring it back and then I can put the limits, which are from 1 to 3. Sorry, 1 to pi over 2. No, 0 to pi over 2. Okay. So this is now going to give me equal to cosine of pi over 2 minus cosine of 0 is equal to, the cosine of pi over 2 is 0, so I get cosine of 0 minus cosine of 0 is 1, so cosine of 0 is 1. Now cosine of 0 is 1, so this gives me the final answer, 1 minus cosine of 1. So this is how we do these definite integrals by using substitution. Okay, that's it for section 5.5, and the rest of the sections you should be able to watch the videos and try to understand them. Now we will go to next time chapter 6.